Welcome to the lecture on power series solution. In this lecture, I am going to discuss about orthogonal property of the Bessel's differential equation and also the problems on Bessel's differential equation. So first let me prove the orthogonal property of the Bessel's function. So statement of the theorem. So if alpha and beta are two distinct roots of jn of x is equal to 0, then integration 0 to 1 x into jn alpha of x jn beta of x dx will be equal to 0 only if alpha is not equal to beta. Proof. We know that y is equal to jn lambda of x is a solution of the equation x square d square y by dx square plus x into dy by dx plus lambda square x square minus n square into y is equal to 0. So consequently, if I take two roots like u is equal to jn alpha of x comma v is equal to jn beta of x respectively satisfy the above equation. So I'm taking two functions here, u is equal to jn alpha of x and v is equal to jn beta of x. So I'm going to assume that these two equations are going to satisfy this equation. It means that in the place of y, I'm going to replace u for one equation, and in the place of y, I'm going to replace v in one equation with respect to lambda is equal to alpha and with respect to lambda is equal to beta. So on replacing the equations like this, I will get x square u double dash plus x into u dash plus alpha square x square minus n square into u is equal to 0. One more is x square v double dash plus x into v dash plus beta square x square minus n square into v is equal to 0. Call this one as equation number 2. So now I am going to multiply equation 1 with v by x. So since the equation 1 is is in terms of u variable, so I'm going to multiply the equation with v by x and I'm going to multiply the equation number 2 by u by x. So if I multiply like that, I will get the equations like x into v u double dash plus v u dash plus alpha square uvx minus u square uv by x is equal to 0. For the equation number 2, I will get the equation like x into v double dash plus u into v dash plus beta square uvx minus n square uv by x is equal to 0. So now on subtracting these two equations, so I will get the equation like, so on subtracting the 1 and 2 equations here, I can take x common factor. So remaining will be vu dash minus uv dash. Here vu dash minus uv dash plus alpha square into beta square by taking uvx common factor. So since it is common from in the both the equations, I can take common factor and subtracting these two, it will become 0 is equal to 0. I got it. So I can replace this complete term as d by dx of x into vu dash minus u into v dash. You can see here by applying the product rule. So I can keep this x as it is. Differentiating this equation, I will get v into u double dash minus u into v double dash. I will get it. Plus again, if I keep this term as it is, differentiating the x function, I will get 1 here. And here I am taking negative common factor, shifting this term to RHS. I got the equation like d by dx of x into vu dash minus uv dash is equal to beta square minus alpha square into x uv. So now to eliminate this d by dx, I am going to integrate both the sides. So now integrating both the sides with respect to x between the limit 0 to 1, I will get x into vu dash minus uv dash between the limit 0 to 1. So since there d by dx got eliminated, we got the equation like this. In the RHS part, since beta square minus alpha square is a constant, I can take outside. Integrating between the limits x from 0 to 1, x into uv dx will get it. So on applying the upper limit, So x will become 1 here. I got v into u dash minus u into v dash. For the lower limit, x will be equal to 0. The whole term will be equal to 0. I will get it. Is equal to beta square minus alpha square integration of 0 to 1 x u v dx. Since here u is a function of j and alpha x, v is a function of j and beta x, we have u dash is equal to alpha into j n dash of alpha x, v dash is equal to beta into j n dash of beta x. And we have, on replacing these values in the above equation, I will get the equation like jn beta of x alpha into jn dash of alpha x minus jn alpha x beta into jn dash of beta x at x is equal to 1 is equal to beta square minus alpha square integration 0 to 1 x into jn alpha x jn beta x dx. So it will be equal to integration 0 to 1 x into jn alpha of x jn beta of x dx is equal to 1 by beta square minus alpha square into alpha into jn beta of x jn dash of alpha minus beta into jn alpha jn dash of beta. Call it as equation number 3. So since we have the alpha and beta are distinct roots of jn alpha of x is equal to 0 and jn beta of x is jn of x is equal to 0, so it will be equal to jn of alpha is equal to 0, jn of beta is equal to 0. So if I replace jn alpha is equal to 0, jn beta is equal to 0 in this equation, the whole term will be equal to 0. So I got the equation like integration 0 to 1 x into jn alpha x jn beta x dx is equal to 0 if alpha and beta are not equal. So next is, so let me see some problems on Bessel's differential equation. The first problem is solve 16x square y double dash plus 16xy y dash plus 16x square minus 1 into y is equal to 0 in terms of Bessel function. So the first thing is we have to convert the given equation in terms of Bessel differential equation. Actually the Bessel differential equation is given like this: x square y double dash plus xy dash plus x square minus n square into y is equal to 0. So now from this equation I will take 16 common factor to get the equation in terms of Bessel differential equation. So if I take 16 common factor from all the equation and equating it to RHS, I got the equation like x square y double dash plus xy dash plus x square minus 1 by 16 into y is equal to 0. Call it as equation number 1. So now by comparing this equation with the actual Bessel equation, I got n square is equal to 16, 1 by 16. So now the solution of the Bessel equation is given by y is equal to a into jn of x plus b into j minus 1 of x. So by comparing 1 and 2, I got n square is equal to 1 by 16. So n will be equal to plus or minus 4. So by replacing this value in the equation, I got a solution like y is equal to a into j 1 by 4 of x plus b into j minus 1 by 4 of x is the solution for the given differential equation. So next is solve y double dash plus y dash of x plus 1 minus 1 by 6.25 x square y is equal to 0 in terms of Bessel equation. The first thing is convert the given equation in terms of Bessel differential equation, that is x square y double dash plus xy plus x square minus n square into y is equal to 0. So to get that equation, I am going to multiply the entire equation with x square. So if I multiply the equation and rewriting the value 6.25 as 25 by 4, so it will be equal to 5 by 2 whole square. So I got the equation like x square y double dash plus xy dash plus x square minus 2 by 5 whole square into y is equal to 0. On comparing this equation with the actual Bessel equation, I got the value as n is equal to 2 by 5. So from the solution of the Bessel differential equation, we have y is equal to a into jn of x plus b into j minus 1 of x. In place of n is equal to, if I replace 2 by 5, I will get y is equal to a into j 2 by 5 of x plus j minus 2 by 5 of x is the required solution for the given differential equation. Thank you.